Okay, let me continue. So if you look at your e-class, you can find Jupyter notebook file. So let me explain a little bit about the code. So I want to create a dictionary. So as you might know, the dictionary is a data structure with the curly bracket. Okay, so this is the curly bracket. And we have key and value. Okay, so this is the K and this is V. So how many items do we have? How many items do we have? 1, 2, 3, 4, 5. Okay, there are 5 items. Now, let's say I want to remove a particular item and return its value. So we can just call the name of the dictionary, which is squares, and then pop. So pop means we want to remove. So we want to remove the key, which is 4, and the value is 16. So we will get value 16. And then if you want to print all the values with key, then we can get this one. 1, 1, 2, 4, 3, 9, and 5, 25. So the 4 has been removed. Let's say I want to remove an arbitrary item. So arbitrary means random. So let's say based on this code, the randomize will determine this key. So this key will be removed. And then the output will be this one. If you want to remove all items, you can just use clear. Then all items will be removed. So when you print the squares, then it will be empty. Okay, let's see. Okay, so the result will be something like this one. If you want to delete, so you can delete the squares. The square means the variable of the dictionary. When you delete, then you cannot print again. So the value or the variable square has been removed from the memory. So name squares is not defined. We can make a dictionary comprehension. So some of you in the mid exam, you already know how to create the comprehension. It means you put the code in one line. So it's good. In this case, I want to put the squares where the x is the key and the value will be x multiplied by x. So if the x equals to 2, then the value will be 4. If the x equals to 3, then the value will be 9, and so on. And x will be in range 6. What does it mean? 6. It will be 0, 1, 2, 3, 4, 5. Okay, before 6. Then you will see the result like this one. When it is 0, 0 multiplied by 0 is 0. When it is 1, 1 multiplied by 1, it is 1. When it is 2, 2 multiplied by 2 is 4. When it is 3, 3 multiplied by 3, it is 9. When it is 4, 4 multiplied by 4, it is 16. when it is 5, 5 multiplied by 5, it is 25. Okay. So that's the meaning by this dictionary comprehension. Okay. So we also have the list comprehension, we have dictionary comprehension. So you can also do like this one. You can determine the dictionary as empty, and then you can do the for loop for x in range 6, and then we have the squares. The squares of x, it means I have the key. Okay. The key is the x, and then the value will be x multiplied by x. Then the result will be the same with this one. So you can use this dictionary comprehension, or you can use this dictionary with for loop. You can also use the dictionary comprehension with if conditional. So for example, if the condition x modulo 2 equals 1, what does it mean? X modulo 2 equals to 1. It means this is odd number. Okay. 1 modulo 2, then it is correct or it is true. 3 modulo 2, okay, this is true. 5 modulo 2, this equals to 1. Okay, this equals to 1. 7 modulo 2, then it is also 1. Okay. So we want to get only the odd numbers. And then we will do the loop from 0 until 10, because the range is 11. So it is 0, 1, 2 until 10. So if you print this one, then we will get the value 1 is 1, 3 is 9, 5 is 25, 7 is 49, and 9 is 81. Okay. So I can also check whether the key exists or not. Okay. Let's say I'm using the squares, and then I define 1 as the key, 1 is the value, 3 and 9, 5 and 35, 7 and 49, and 9 and 81. So I want to check whether 1 is in squares or not. So you use in. I also can check with not in. So in means I want to know whether does this key exists in this map or not. I want to check whether this key not exists in this map or not. So membership test for key only, not value. So I want to check whether 49 available in the squares or not. Actually, we know that 49 is in the square, but 49 is not the key. That's why the output will be false. Okay, so this in, not in, only available for the key. Okay, this is only for key. We can do the iteration through a dictionary. Okay. So we have 1, 3, 5, 7, 9, and then I want to do the loop for I in squares. Then what we can get is the value. The value will be printed whenever you call the variable from the map with the key. So this is the key. When I equals to 1, the value is 1. When I equals to 3, the value is 9. When the I equals to 5, the value is 25, and so on. Okay. So we can also do with different ways of dictionary. Now let's say I have a dictionary, my dictionary, and I have 3 fruits: apple, banana, and cherry. So let's say this is the value. I have 1 apple, I have 2 banana, and I have 3 cherry. So 1, 2, and 3 are the value associated with those key. For example, it is the number of fruits that we have in the inventory. Just example. Okay. So you can design your data structure like this one. And we can see about the value for every key. For example, I want to know what is the value of apple. So I want to know what is the current inventory status of apple. So I can call with my dictionary, which is the name of the dictionary, and call the key. So the key is apple. Then I can get the value of apple is 1. So I know that the inventory of apple is 1. I want to know the inventory of grape. Is there any grape? No, we have only apple, banana, and cherry. There is no grape. Then we can add new data. So if we have this one, my dictionary grape equals to 4, it means that if there is no value of grape, we will add this data. Then after we add the dictionary, after we add the grape, we will get a new dictionary: apple 1, banana 2, cherry 3, and grape 4. Let's modify the data. So we have banana equals to 5. Then, oh, okay. I didn't print this one. Okay, I need to print this one. Okay. The dictionary after modifying banana. Okay. So after we modify the banana, we can get the banana equals to 5. Obviously, is 2. And now we want to delete cherry. So we just remove the key where the key is cherry. So we get only remaining data like apple 1, banana 5, and grape equals to 4. So we can also use in with the if function. For example, if apple is in my dictionary, then print apple. If it is not, so we can put else. So we can say apple is not in the dictionary. I will check cherry, whether cherry is in the dictionary or not. If it is yes, then we will put cherry. If it is not, then we will put cherry is not in the dictionary. So if I run, yeah, you can see apple is in the dictionary, cherry is not in the dictionary. I want to check how many items do I have, so I can use length. And then I can also check the iteration. The iteration means I want to see the key and value in the dictionary. So the dictionary, as I mentioned before, I want to know the items. So we have three things. We have items, we have key, and we have values. If you want to look at the K and V, you can use items. So in this case, I have key and value. So I want to show the items. So for every of the key and for every of the value, it will be in the key and value will be repeated from the dictionary. So in this case, it is the iteration key apple value 1, key banana value 5, key grape value 4. Okay, this is just another way to do the iteration. I want to get the key and the value. And then let's say I want to get the apple. Okay. So I want to get the apple. It means I want to know the value of apple. Then I can get the value of apple, which is 1. Okay. So those are the basic of the dictionary. Now let's see. When we use the map, it is a kind of base. So the map can be split to different kind of class. So if you already know the superclass, so the superclass, it is the map. And then we can make the subclass. The subclass, it can be the table map, hash map, sorted table map, tree map, and then in the hash map piece, we can have chain hash map, we can have probe hash map. So I think I will not explain all those things. Okay? So if you have interest on those map, you can learn by yourself on some of them. I will just explain the map base and the hash map. What is the meaning by hash map in the next slide? And then next slide, we will also learn about the tree map. So this is the map base. So in the map base, if you want to make the abstract class, so you can have the two variables, which is the key and value. So in the constructor, you have K and V. K refers to the key, V refers to the value. And then you can check the equality. So if we have the EQ, means I want to check whether the key equals to the other key or not. If the not equal, so it is the opposite. And if it is less than, so we can also compare if the key is in the number. If the key is in number, so you can put the less than. Why? Doesn't work. Oh. So if you can see from here, there is a class unsorted table map. So this unsorted table map, it is a subclass of map base. So you can see already, this is the inheritance. And if you look at this one, the constructor is a list. So we can make a list. And then when we want to get, So the get item means I want to get from the key equals to k. So for item in self table, so I can check with in. So I want to check only the key k that exists in the dictionary. So if it is not available, then it will show. And then I can set the item k comma v. So if item is in the table, then check whether the k is the same with the key. If it is the same, then let's put the value equals to v. So if you cannot find any match for the key, then you will add a new items in the table. So you can append. If you delete the item, then first you will do the loop. So you will check for all the data in the table and then check if the k is equal to the key in the dictionary or not. If it is the same, then you can pop. Pop means you want to remove. If you can find it, you can remove it. But if it is not, you will show the error. So we want to check the length and we want to do the iteration. So if we use the list, list is using the square bracket, inserting an item takes O1. Since we can insert the new item at the beginning or at the end of the unsorted list. Searching or removing an item takes O(n) time. So this O(n), it means the worst case. Okay? The worst case means if the item is not found, then we traverse the entire list to look for an item with the given key. So if we cannot find at the first key, we go to the next key, we go to the next key until the k n. That's why the worst case will be n time. The unsorted list implementation is effective only for maps of small size or for maps in which insertion are the most common operations, while search and removal are rarely performed. So using the dictionary or using the list-based dictionary, if you want to have a big size, if you want to have a big size of data, it will not be optimized. So this list-based map, it is good for small size. So let's move to the next section, which is about the hash table or hash map. So in the hash table, there are some concepts about what is the hash tables and then what is hash functions and what are the issues on the collision. Why? So the definition of hash table is something like this one. Let's say we have a map. We have a map, and a map supports the abstraction using keys as indices with the syntax such as mk. So I can call the key k, and then as a warm up, okay, let's consider a restricted setting in which a map with n item use keys that are known to be integer in a range from 0 until n minus 1. So I have a limitation on the map, and the map will be only for 0 until, let's say, n minus 1. So n minus 1, it will be determined by the number of the data. It can be also not equals to the big N, but there's also the small n. So big N means the number of the data, and the small n, it is a range of another integer that limit the size. So for example, like this one. We have the key to represent indexing in a list with number like 0, 1, 2, 3, and let's say until 10. Okay. So the key is the integer. This is very simple. This is very common. Yeah, you can use in a list. But what should we do if our keys are not integers? So you already see from the example. Let's say the key is apple. So this is not integer. The key is banana. It is not integer. And the other thing, for example, you know the Jumin dan Ponho. Okay. Your security ID, your national ID, it is a number. Maybe your number is 000516. So it means you were born in 2000 on May and 16. And then you will have another number. So this number represents an ID, and it is unique. But this is not integer. So this will be, in many cases, we will have this kind of key, and we need to have a function. A function to map the general keys. This is the general keys, or the Jumindanokunu, to the corresponding indices in a table. So the table will use only 0, 1, 2, 3, 4, 5, and so on. But now we will try to figure out, if we have this kind of number, how we represent in this integer. So sometimes we will do like this one. For instance, the last 4 digits of the social security number. So the easy one, okay, if this one is 0001, let we put it into the index 1. If this one is 0002, let we put it into the index 2. If this one 0004, let's put it into the index 4, and so on. So there should be a function, and we call it, this is a hash function. So hash function, it is related with the hash table. So a hash function, it maps the keys of a given type of integers in the fixed interval. So we have a fixed interval from 0 until n minus 1. So it means we have a limit of the table. So the table, there will be only 0 until n minus 1. In this case, we can have a function. For example, this is a simple function, or this is a general function. This is a general function with the mode. Mode, do you know mode? Mode means modulo or remainder, namoji. So I want to know if I have the x mod the n, which is the size of the table, then we can use this function. And because this is the hash function for the integer keys. Every integer its x is called the hash value of the key x. So let's say if I have x, okay, so x is the key, maybe 0, 0, 0, 1. Then what is the value? The value will be 1. If I have the key is 0, 0, 0, 2, then the value will be 2. So something like that one using this function. So a hash table for a given key type consists of hash function, which is this its, and then array, or we call it as a table, and the size is n. So when we implement a map with the hash table, so the goal is to store the item k. So we want to save the object O in the key k at the index I. And the index I is from the function its k. Maybe we can see from one example. So we use the social security number. Let's say this is SSN. Okay, SSN is the social security number. So we want to design a hash table for a map storing the entries, and we want to save the SSN and the name. So SSN is the social security number, is a 9-digit positive integer. It's 9 digit, 9 digit. Oh, okay. So this is any digit from 0 until 9. So our hash table use an array of size n. Let's say the n is 10,000. So I have a room from 0 until 9999 because the n is 10,000. And the hash function is its x with the last 4 digit of x. So the last 4 digit of x. So here, the last 4 digit. Because we have 9999, and we put this 4 digit. If this is 0001, we put into key equals to 1. If it is 0002, we put this one into the key equals to 2. If we have 9998, we put this one into the key 9998. So another example. We have this key. We have 11 items. Sorry, we have 11 capacity. Okay, so n equals to 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, I have this one, 1, D, 25, C, 3, F, 14, Z, and then 6A, and then 39C, and 7Q. Okay. Now, I want to put for every item in this bucket. Okay, we call it bucket. So this bucket, we have n equals to 11. Okay. Then with the general hash function, it's x. The problem will be, what is it? X mod n. Okay. So its x will be x mod n. So x is the key. Now, for example, we have 1d, 1 comma d. So the key is 1. So 1 what is this n? The size is 11. So 1 mod 11. What is 1 mod 11? It is 1. Then we put 1 comma d into the index 1. Okay, so we have 1 comma d here. Now let's see. 25 comma c. 25 comma c. With the size 11, n equals to 11. Again, we have the its x, which is x mod 11. So x in this case it is 25. 25 mod 11, that is 3. So we put this item into the index 3. We put this item into the index 3. Okay. And then let's say 3f. Okay. 3f. 3f. So we have another, it's x mod 11. So 3 mod 11. This is 3. Then we put 3f into the index 3. Okay, then we have another 3f. So we call this is a bucket. Because in one index, there might be multiple items. Okay. So hash function, it means that a hash function is usually specified as the composition of two functions. The first is we have the keys, and the keys we want to create it as integer. In the previous one, in this case, we already have the key as integer. This is okay. But what if the key is not integer? When the key is not integer, for example, apple, how can we know that apple is able to be converted to integer? So there is another way, okay? But I do not want to discuss that one. So let's say I have another key. So the key is, we have like 4 digit 0009. So I want to change this one into integer. Okay. And then, we call this is the hash code. So for any keys, we want to convert it into integer. And then we have the compression function. The compression function means we have the integer from this one, and we want to compress it into the size of our array. So the size of our array is between 0 until n minus 1. Let's say the n equals to 11, then this is the array between 0 until 10. So the hash code is applied first, and the compression function is applied next. The hash code is applied first. The hash code is applied first, and then the compression function is applied next. So we can get the function something like this one. Hx equal to h2, this is the compression function, of h1x. So the goal of the hash function is to disperse the keys in an apparently random way. So we want to know how we can put this value into an array in random. So there are some hash codes. Okay, of course, this is only just general knowledge. You don't need to memorize it. Okay? This is only the general knowledge. So in some of the hash code, we can put the memory address. In a computer, we have a memory address. We reinterpret the memory address of the key object as integer. It is good in general, except for numeric and string keys. And there is also another hash code, we call it integer cache. So we can reinterpret the bits of the key as integer. Bits. Okay. So if you understand how the electronics works, okay, we can use the bit of the key. It is suitable for keys of length less than or equal to the number of bits of integer. Or we can also use the component sum. So the component sum means the partition the bits of the key into components of fixed length. For example, 16 or 32 bits. And then we sum the component. It is suitable for numeric keys of fixed length greater than or equal to the number of bits of integer types. So there are many ways to code from the any keys to the integer. And it depends on how the hash works, especially the hash codes in the computer. Okay, I think I will stop here. Okay, I will continue on Monday. Any questions?